In this video, I am gonna explain how to select all loads and lines and calculate the parameters and put the results in a separate CSV file. So, let us open an example of DIgSILENT software. For example, this 14-bus system. In the previous video, we discussed about the introduction of DPL or DIgSILENT programming language, and we created a new study case as DPL introduction, so we don't need to create another. Go to Open Data Manager, and from our active study case, click on DPL introduction. Then from New Object, create a new DPL command. Let us name it as example 04. Then select your general selection. As we discussed, that the general selection can be specified through selecting one or more elements in the single line diagram. Then right-click on the selected elements and from Define, choose DPL command set. Or it is possible to select several elements from the edit relevant objects. Here you can select either all elements or you can select one of these elements. Then select all, right-click, from Define, click on General Set and close it. Now let's go back to our DPL command. Select the General Set. In the script, it is the place to write our program code. First of all, let us define our variables that we are going to use. Int error set st object o1 o2 semicolon. So now let's write a program that can run a load flow calculation. Error equal to load flow dot execute close bracket semicolon. It means that the load flow is calculated by calling the method execute of the load flow command. So here for the executing of load flow, we need to create a new object for load flow calculation in this example. Select the example, then click on New Object, and from the element, select Load Flow Calculation. Then click OK, and click on Execute. Let us name it Load Flow. Click Enter to save it. Come back to our example. Let's create an if statement to evaluate the test condition. If our test condition is evaluated to true, this will be executed and the program will be terminated. If the condition is evaluated to false, this will not be executed and the else statement this time will be executed. In the else statement, first of all, let's write a program that takes all loads which were selected in general selection. So we can use the object SEL to reserve object variables. S equal cell dot all loads close bracket semicolon. Then write a printf function to print the parameters onto the output screen. Printf load name voltage kilovolt, active power kilowatt, reactive power kVAR, O1 equal to S dot first close bracket semicolon. It means that AC is calculated by calling the first load using the method S dot first close bracket semicolon. To reach all loads, we need to write a while loop. While take the object O1. Let's write a printf to evaluate the parameters onto the output screen. Printf %s for the load name, %0.2f, calculate the voltage for two decimal numbers, %0.2f, %0.2f, the same for active power and reactive power. Write code for the load name and the other parameters. We can get help from the edit relevant object. Let's check it. Click on general load, then click on flexible data. If you put your cursor on name, you will notice the code that is parameter name colon log underline name. Let us write it. The parameter name here, it is O1. O1 colon log underline name. Let's check the voltage, active powers and reactive power codes. Again, go to edit relevant object. Click on general load, then select flexible data, and over here click on define flexible data. Select basic data. Variable set must be on reference parameter. Then click on bus 1. Select load flow and put the variable set on currents, voltages, and power. Then select line-to-line voltage magnitude U1. You can select in per unit or line-to-ground voltage magnitude. Then select the P load and Q load. General load, active power, and reactive power. Click OK. Now you can see all the code addresses of line-to-line voltage magnitude, active powers and reactive powers. So let's write them on DPL command. O1 colon R colon bus 1 colon M colon U O1 colon R colon bus 1 colon M colon P load O1 colon R colon bus 1 colon M colon Q load. O1 equal S dot next close bracket semicolon to get next loads. Continue semicolon. Now all loads are accessed. Let's execute it. As you can notice that our DPL program is successfully executed. Let us increase the distance between these parameters. Now it looks better. Line-to-line voltages, active powers, and reactive powers are calculated for all loads. Now let's write a program to calculate the parameters of transmission line. And go back to the DPL command, the same as the load. Firstly, write a program that takes all lines which were selected in general selection. Again, use SEL to reserve object variables. T equal cell dot all lines close bracket semicolon. Then write a printf function to print the parameters onto the output screen. Printf line name, line length in kilometer, sending bus, sending voltage, sending phase angle, sending active power flow, sending reactive power flow, receiving bus, receiving voltage, receiving phase angle, receiving active power flow, receiving reactive power flow, semicolon. Similarly, do the same thing as we did in the load part. O2 equal T dot first close bracket semicolon, while O2 printf line name, length of line, sending bus, magnitude of voltage, phase angle, sending active power flow, sending reactive power flow. Receiving bus, receiving voltage, receiving phase angle, receiving active power, and receiving reactive power. Write the address of line name O2 lock name. Then length of line O2 E D line. And the sending bus O2 R bus 1 R C term E lock name. You can get help from the edit relevant object to access these code addresses, as we did in the load parts. Let's look and check it. Go to the edit relevant objects, click on line, then select flexible data. If you put the cursor on each of these parameters, we can access to each of these code addresses. To access the code address of voltages, phase, angles, and powers, go to Define Flexible, select Basic Data, put variable set on reference parameter, and click on bus 1. Select load flow and put variable set on currents, voltages, and powers. Then select line-to-line magnitude voltage, the voltage phase angle, the active and reactive power flow. Click OK. These are the code addresses. Let's write them on DPL command. O2 R bus 1 M U1. Copy it and paste it here. For the phase angle, change U1 to phi and change this one to P flow and this one to Q flow. Copy all these sending parameters for the receiving bus. And change only bus 1 to bus 2. To get next line, write O2 equal T next, close bracket, semicolon. Continue. Check the code. Oops. There is an error. Check the output. Semicolon is missing. Put the semicolon and check it again. Error is eliminated and executed. Now our example is executed successfully. To see all these parameters better, let us arrange our code and increase the distance between them. It looks better now. Okay, let's put all this data in a separate CSV file to have an easy access to them. To do that, let's write if open function to write file as CSV. First, write the path address, the name of the file, .csv. W here means writing the data. 0 means number of file handler. Since we print file, we should use fprintf and also add number of handler to fprintf. Do the same thing for the others. Check the code and execute it. Our DPL program is executed. Let's see the file and open it. As you can see, all our data are saved as CSV file. Notice that if your computer has an old Office version, it may not open the CSV file in Excel. Guys, I hope the video could help you. Thank you for watching.